Picture this. You're watching a sleek, new EV silently glide down the street. It's the absolute pinnacle of clean, green technology, right? Well, maybe not. Beneath that shiny exterior and whisper-quiet ride is actually a massive hidden vulnerability. It's a huge problem that the entire EV industry is desperately scrambling to fix. So today, we're dialing into a mind-blowing breakthrough that could completely rewrite how electric vehicles are built from the ground up. So what exactly is the EV industry's biggest hidden vulnerability? Now, you might immediately think, oh, it's the lithium-ion batteries. But there's actually another crucial component sitting right next to that battery. To actually get the wheels turning, almost every EV on the road today relies on materials that are incredibly toxic to extract. And get this, they're almost completely monopolized by a single country. The scale of this issue is honestly staggering. 90%. That is the share of the rare earth minerals needed for today's EV motors that is controlled by just one nation. Think about that. That's a massive global supply chain bottleneck just waiting to snap. Section 1. The EV industry's secret. Okay, let's break down the tech. The industry standard today is what we call the PMSM, or Permanent Magnet Synchronous Motor. It is highly efficient, and it gives you that fantastic instant torque we all love in EVs. But to pull that off, it relies on physically embedding these specialized neodymium iron boron permanent magnets directly inside the motor's spinning rotor. Now, these physical magnets are exactly what make the motors so effective, but they are also its absolute Achilles heel. Because here's the catch, physical magnets have some pretty serious flaws. First up, heat. Above a certain temperature, these magnets literally start losing their magnetic properties. Not great for a high-performance car, right? Second, efficiency actually drops off at high speeds because of competing electrical forces inside the motor itself. And finally, physical magnets just degrade over time. It's inevitable. Which sets up a really fascinating question. What if we could somehow bypass these physical hardware limits entirely, using software? Section 2. China's rare earth monopoly. When we look at the global supply of the permanent magnets used in these high-powered electric motors, the numbers are wild. China commands a massive 94% market share. That leaves the entire rest of the world fighting over just 6%. This level of concentration makes the global automotive and even aerospace industries incredibly vulnerable to sudden price spikes or export controls. And it's not just a geopolitical headache. There is a genuinely dirty secret to this green tech. You see, refining these rare earth minerals requires this chemical leaching process, and that process produces highly toxic, radioactive thorium waste. It's incredibly difficult and super expensive to manage safely. In fact, that's a big reason why a lot of countries just outsource this refining capability entirely in the first place. Which brings us to Manish Seth, the CEO of Vimag Labs. Back during the first wave of COVID lockdowns in 2020, a critical shipment of permanent magnets for his startup's prototype motors ended up stranded at a Shanghai port for 3 excruciating months. He later said, "I had gone through that pain. That's how the idea of the total magnet-free, rare earth-free motor started." Basically, it was a massive supply chain nightmare that sparked a totally profound technological pivot. Section 3. The virtual magnet breakthrough. And this is where the paradigm totally shifts. On one side, you've got the traditional PMSM. It's hardware dependent, relies on those physical rare earth magnets we talked about, and it degrades over time. But on the flip side is Vimag's breakthrough, the VMSM, or Virtual Magnet Synchronous Motor. It is entirely software defined. It uses standard, easy-to-get copper and steel, and crucially, its magnetic properties can actually be updated over the air. Yeah, just like an update on your smartphone. They are literally replacing a finite physical material with code. Section 4. Replacing hardware with software. Now, usually, if you want to ditch permanent magnets, you have to use physical brushes or slip rings to transfer power into the spinning rotor. But those create a ton of friction and they wear out fast. Vimag entirely eliminated those contact points. Here's how it works. Step 1, the battery sends power to the motor's stationary part, the stator. Step 2, they use a patented wireless inductive transfer to energize standard copper coils inside the spinning rotor. And step 3, this is the magic, the software dynamically adjusts this newly created magnetic field in real time, based on exactly how much power the vehicle needs at that exact millisecond. The absolute secret sauce to pulling this off? Sheer speed. By leveraging advanced machine learning algorithms, Vimag software calculates and tweaks the rotor's magnetic field over 20,000 times per second. It's constantly predicting the absolute most efficient combination of the rotor's magnetic field and the stator's torque. They're essentially spinning up a highly tuned, super efficient electromagnet on the fly. Section 5. Better performance, lower cost. So what does this actually mean for performance? Well, with the traditional setup, you're at the mercy of completely volatile rare earth supply chains, and you're stuck with hardware that slowly degrades with heat and time. But with Vimag's software-driven motor, you are using local, super stable materials like copper and steel. And it gets better. At low speeds, their VMSM actually delivers 20 to 30% higher torque than the baseline for the exact same amount of current. Plus, because it's software-driven, the motor can literally get better over time with over-the-air updates. You're completely sidestepping wild material price swings while getting undeniably better performance. It's a huge win-win. Section 6. Scaling the magnet-free future. Since that painful supply chain crisis back in 2020, Vimag Labs has moved incredibly fast. They raised a $5 million Series A round led by Accel in 2024. Now, looking at 2026, they're already targeting pilot production batches of anywhere from 1,000 to 10,000 units. And they've already secured 5 granted Indian patents for their core tech. But looking a bit further out, they are planning a massive hardware evolution, a custom ASIC chip. By developing their very own proprietary semiconductor, that custom ASIC chip, Vimag aims to shrink their electronics costs by up to 90%. That effectively wipes out their last potential supply chain bottleneck. With that foundation in place, they plan to expand way beyond just two-wheelers and passenger cars, moving into heavy-duty trucks and buses. They're even looking into defense and robotics applications, not to mention using their advanced inverters to enable vehicle-to-grid or V2G integration. Which leaves us with this final, incredibly provocative thought to chew on. If software can completely replace the physical rare earth core of an electric vehicle's motor, what other hardware is about to become totally obsolete? We are entering a fascinating era where software-defined hardware is literally rewriting the rules of global manufacturing and supply chains. Thank you so much for joining me on this explainer today. If you want to dive deeper into Vimag Labs and all the incredible nuances of this technology, be sure to check out the description for links to the full source articles. See you next time.